So when we started solving equations, we talked about sort of three central questions. The first question was, are the trig functions the same? And that was pretty much a central question for a lot of the problems you did for homework. A lot of those problems, you rewrote them so the trig functions were the same, or if they were not the same, you looked at a way to possibly factor. Today we're going to look at the question, are the angles the same or are they multiples of each other? So what I mean by that is, instead of having sine x equals a half, what happens when we have sine 2x equals a half, for instance? So we're going to take a look at the problems for today, which are right here. And the first one I want to look at is this 2 cosine minus 1, or 2 cosine 3t minus 1. And notice our domain values are going from 0 to 2 pi. But the angle is 3t. Our angle here is 3t, and our domain is 4t. So as we solve this, we need to do what's called adjust the domain. So I'm going to adjust the domain. And when I adjust the domain, I'm basically going to rewrite this statement so it's for 3t instead of t. So I'm going to multiply that entire inequality by 3. So I get 0 is less than or equal to 3t, which is less than 6 pi. So now when I solve the angles that are 3t, I'm going to look for all the angles from 0 to 6 pi instead of just 0 to 2 pi. Mark?
Just multiply by 3 then?
That's what I did, yeah. Yeah, just multiply by 3. Okay, so let's solve this. Let's solve for the angle, or the trig function. If I solve for the trig function, I have cosine 3t equals 1/2. I just add 1 and divide by 2. And now I'm going to draw a reference triangle such that the adjacent side over the hypotenuse is 1/2. And remembering that cosine is positive in the first and fourth quadrants, in order for the adjacent side to be 1 and the hypotenuse to be 2, we're going to have this kind of a 30, 60, 90 triangle. So we know this little reference, whoops, that's a 60. This little reference angle is 60 degrees, right here, or pi over 3. So I'm going to start naming the angles, and I have to name the angles from 0 all the way to 6 pi. So if I start here, the first angle that is equal to 3t is pi over 3. And then the next angle, this one, is 5 pi over 3. And then this is going to get a little bit messy. But the next angle, so that takes care of all the angles from 0 to 2 pi. So now I want to consider, I have to go all the way to 6 pi. I want the angles from 0 to 6 pi. So if I was going from 0 to 2 pi and then continuing, I would end right here. That would give me an angle that's in that region from 2 pi to 4 pi. So basically all I did was add 1 rotation. So I'm going to add 1 rotation to the pi over 3. All right? 1 rotation is 2 pi, and that's the same thing as 6 pi over 3. So I'm going to add 6 pi over 3 to pi over 3 and get 7 pi over 3. I'm going to also add that to 5 pi over 3 to get 11 pi over 3. So there I've added, so now I've considered, these are all the angles between 0 and 2 pi. These are the angles between 2 pi and 4 pi. And I still have to consider the angles from 4 pi to 6 pi. So now I have to add not 1 rotation, but 2 rotations. So 2 full rotations would be 4 pi, and in terms of thirds, that would be, here I just multiply by 3 over 3, so that's going to give me 12 pi. So I have to add 12 pi thirds to my original 2 angles. That will accommodate for adding 2 full rotations. So if I add 12 here, I get 13 pi over 3. Adding 12 here gives me 17 pi over 3. That solves for 3t. Maddie.
Couldn't you just add 6 pi over 3 to like 7 pi over 3 and
Yeah, you can do that as well. That's fine. Yeah. I was trying to emphasize here that, you know, this is 1 more rotation, this is 2 more rotations, but absolutely, there's no reason you couldn't do that. So let's just notice here, these are the angles that are between 4 pi and 6 pi. Okay, other questions before we go on? Anything else that anyone's confused about what I did so far? Michael?
These are all solutions.
Yes, yes. These are all solutions for t between 0 and 2 pi and for 3t between 0 and 6 pi. So in the process of solving for t, we had to adjust the domain and solve for 3t. So now let's go back and let's actually solve for t. If these angles are equal to 3t, then t would be equal to 1/3 of those. I would just divide both sides of this equation by 3. I could divide here by 3, and then I would have to divide by 3 in each one of these fractions. So I would, you know, divide by 3, divide by 3, divide by 3, etc. I'm just doing the same thing on both sides of an equation. So I end up with pi over 9 and 5 pi over 9 and 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. And if you wanted to check this, you could graph this in your graphing calculator. You would graph this equation right here, and you would graph it for this domain, just 0 to 2 pi. And if you did that, you would see that the graph crosses the x-axis at each of these 6 places. So, you can do that in your spare time, or if we have enough time at the end of this lesson, we'll do an example like that. Okay, so I'm going to clear this and go on to another problem. This next problem, number 2, is 4 sine squared 2x equals 3. So we're going to use the same process. We're isolating the trig function. So when I isolate sine squared 2x equals 3/4, and then take the square root of both sides of the equation, I have sine 2x equals plus or minus root 3 over 4, and that's the same thing as plus or minus root 3 over 2. Now I notice again I have a double angle. My angle is 2x, so I have to adjust the domain. I'm going to multiply through by 2 this time. So I get 0 less than or equal to 2x less than 4 pi. So I know I have to check for all of the possible solutions from 0 to 4 pi. Okay, so draw your reference triangle. When I draw the reference triangle, I'm looking at the opposite over the hypotenuse. And since we have plus or minus, we're going to have reference triangles in every quadrant, because in quadrants 1 and 2, the sign is positive. In quadrants 3 and 4, the sign is negative. So we'll have triangles in every quadrant. Drawing triangles such that the opposite side over the hypotenuse is root 3 over 2. And it just so happens that we have a 30, 60, 90 again. So here's root 3 over 2. And then down in the third and fourth quadrants, it's negative root 3 over 2 and negative root 3 over 2. So now we have to name those 4 angles. And so that gives us 2x is equal to, this is pi over 3, because your reference angle there is 60 degrees. This is 2 pi over 3. is 4 pi over 3. And here we have 5 pi over 3. Okay, so that takes care of all the angles from 0 to 2 pi. But my domain, notice, goes from 0 to 4 pi. So again, I have to add one full rotation. Adding one full rotation is adding 6 pi over 3. So now I'm going to have 7 pi over 3. Adding 6 here gives me 8 pi over 3. Adding 6 here gives me 10 pi over 3. And then finally 11 pi over 3. So that's a boatload of solutions. And those all take care of 2 pi to 4 pi. So then finally, to wrap up the problem, I want to solve for x ultimately. So when I solve for x, I have to divide everything by 2. So my x is going to be pi over 3. I'm going to divide by 2 here, and that gives me pi over 6. I divide by 2 here. That gives me pi over 3 because the 2's divide out. Divide here by 2. That's going to give me 2 pi over 3. Dividing here by 2 gives me 5 pi over 6. Dividing here by 2 gives me 7 pi over 6. Dividing here, 4 pi over 3, and then finally we get 5 pi over 3. So those are your solutions for x. Okay? Oh, I sure did. So I'm going to divide by 2 here. Okay. So then I'm going to add to that 11 pi over 6. There we go. Thank you. So those are your solutions. Any questions on that problem? So it's only a little different. It's a double angle this time, so we multiply everything by 2 and then divide by 2. It was squared, so we had to take the plus or minus square root. So, those are things you want to be mindful of. Okay, let's do one more problem. I think I'm going to jump to number 4 here. There is a number 3, but I think I'm going to jump to number 4. This one is what we would think of as a half angle. It's x divided by 2 instead of a double or a triple or something like that. So when we adjust our domain here, instead of multiplying, I guess we're essentially multiplying by a half, or you can think of dividing by 2. So we end up with 0 is less than or equal to x over 2, which is less than pi when you divide by 2. So here the trig function is already isolated. All we have to do is draw a reference triangle. And we know that tangent is negative in both the second and the fourth quadrants. That's where our tangent is negative. So if I draw a triangle such that the opposite over the adjacent are in this ratio 1 to 3, or 1 to root 3, in the second quadrant, it's the root 3 that's going to be negative. In the fourth quadrant, it's the, it's the negative 1 that's going to be, 1 is going to be negative. But notice, we're only supposed to be looking at triangles from 0 to pi. So we don't even have to worry about this quadrant here, because 0 to pi is just this range right here, and it gives us that angle. Okay? This little reference triangle this time is, or the reference angle is 30 degrees. So x over 2 is going to be equal to 150 degrees, or in terms of pi, that's 5 pi over 6. And this time, instead of dividing, we're going to multiply on both sides of the equation to solve for x. So I multiply on both sides by 2, and that gives me 5 pi over 3 when I simplify the fraction. All right, so let's take a moment. Take out your graphing calculators if you would, and let's graph this. If I was going to check this with my graphing calculator, I would graph y equals tangent x over 2, and I have to subtract, or actually I have to add the 1 over root 3. I'm adding 1 over root 3 because I'm essentially setting the equation equal to 0. And then set up your window. Let's make our window so that our x min is 0, our x max is 2 pi, and maybe we'll let our y values go from, say, -5 to 5. And if we've answered this problem correctly, the graph should only cross the x-axis at 5 pi over 3. So you ought to be able to, hit the trace button, hit 5 pi over 3, and it should give you the point where the graph crosses the x-axis at 5 pi over 3. Did that work for you guys? Hopefully you're in radian measure, or radian mode.
She's not
Not capable?